Welcome to FT Training Systems. For the next few minutes, we are going to look at the uniqueness and benefits of the Fire Engineer Training Simulator. Not long ago, training the members of your fire department to operate an apparatus pump required several firefighters to hold fire hoses and flow tens of thousands of gallons of water out onto the ground. Training engineers to operate their fire apparatus the old-fashioned way involved deploying several hundred feet of hose, manned by several firefighters holding nozzles and hoses. The instructor would then tell the student to start flowing water. An estimated 8,000 gallons of water dumped out onto the ground for every 10 minutes of training time. All of this training was done without the benefit of knowing how the student performed. The only feedback available was seeing water flowing out of the nozzle. Any additional training was done on the fireground, and everyone knows that the fireground is not the best place to learn to operate the pump of a fire truck. The Fire Engineer Training Simulator was designed and built specifically to train your apparatus operators how to correctly pump a fire truck, recognize problems as they occur, and be able to take corrective action. Apparatus operator training is often overlooked because it is time-consuming, labor-intensive, and until now, there was no method available to measure whether or not the engineer was operating the pump correctly. Until you experience the loss of control of a real apparatus pump, you cannot learn the true technique of regaining control in a live situation. This is the benefit to the Fire Engineer Training Simulator. Never let your firefighter run out of water. This is why apparatus operations training is critical. Alright, let's see how easy it is to set up the Fire Engineer Training Simulator and look at some of the training scenarios. After positioning the apparatus, we'll attach the hard suction hose to the pump of the apparatus and the bypass valve on the simulator. Next, we'll attach 4 sections of hose to 4 discharges on the apparatus and to the simulator's 4 control valves. This completes the closed loop system. After we plug the unit into a regular 120-volt receptacle, we're ready to start. We'll begin by transferring the water from the truck's booster tank to the simulator recovery tank. After the scenario is selected, we'll enter the appropriate hose links for each discharge valve into the simulator's onboard computer. The simulator comes standard with 10 fog nozzle scenarios capable of over 450 different hose line combinations, ranging from very basic to extremely challenging. The Fire Engineer Training Simulator allows an engineer to flow over 800 gallons per minute through 4 discharge lines without wasting any water. The water for each individual discharge is measured for flow and pressure at the nozzle, and this data is recorded into the simulator's computer system. The first scenario for our demonstration uses 1 1/3/4 and 2 2.5 attack lines, all of different lengths. This will require the engineer to operate the truck at 3 different discharge pressures. The control valves on the simulator are designed to simulate firefighters with nozzles, and they are programmed to open at different intervals. After approximately 2.5 minutes, one of the 2.5 hose lines will suffer a catastrophic hose rupture. Radio communications are a vital component of each training scenario. Our instructor will guide the engineer in determining what has happened, and more importantly, what to do about it.
44, engine 42 AO. We have a hose rupture on the interior line. We need to get this line shut down. Let's line down. Where's our water at? Where's our water at? We need water. Line's ruptured, command. Negative, our line is not ruptured.
When the adverse situation is corrected and the scenario is complete, the instructor and engineer can review the performance of the engineer by viewing the pressure and flow data that was captured by the computer during the scenario. The last scenario for our demonstration uses all 4 discharges. Radio communication skills will be critical for this scenario. This scenario progresses automatically with 3 discharges operating automatically. At this point, the simulator is only delivering enough water to the engine to supply these 3 lines. At a predetermined time in the scenario, the incident commander will call the apparatus operator and request an additional line be charged. The engineer will have to recognize there is not enough water to supply this additional line and advise the incident commander of the situation. When the engineer does this and requests additional water, he will be able to flow the additional line. Thank you very much for your time and interest in the Fire Engineer Training Simulator. If you have any questions, please let us know. Visit us on the web at www.fttrainingsystems.com. Be sure to ask us about our pump testing service as well. Thanks, and have a great day.